struggling with some long-term ankle issues, let's put it that way, that have kept me relatively immobile for the last, about year and a half now. What I want to do today is to report on part of the work that our team has done. And we've done our focus has been on two main things: total factor productivity on agriculture. And we've presented a poster on that, which, I think has been available to everybody. And now we're going to be talking about some of the work that we've done on risk and return to nitrogen application in our study. I want to start by thanking the members of the team. This is truly a team effort, and so the members of the team are most importantly Zhangji Chen. Zhangji is our graduate student who's actually prepared the slides and done the actual work on a lot of the analysis. Then the other members of the team that I think Prasad and Cesar and Curtis and myself as well. So the focus today is on what we can learn, or what things that we can learn from the models that we've developed or that have been developed that integrate yield response with climate weather patterns. Combine that information with information about what's going on in terms of the market. And this is this notion of price risk here. And when I'm underlining that, what I'm saying is we're taking the data, market-based data, to educate ourselves about price risk that the producers face, and then integrate that information in an economic decision framework that takes into account both the profitability and different measures of risk as economists measure it, and see what that would tell us about what an economic model would spit out as an optimal nitrogen rate. Now, a number of times when we talk about this, we fall into a conversation that talks about this as though it's a nitrogen recommendation. That's something that any land grant economist who's been around farmers knows. You don't make any recommendations to farmers as an economist, because every time you do, you're embarrassed. And so it's not a recommendation so much as what we're learning from the model about different possible patterns of risk and returns. And it's not for us to decide how the farm is supposed to allocate things. And we just want to present an economic model of that. So the model is based on APEX simulations. And we have APEX simulations that are over two different, and I'll make this a little bit bigger so you can see it. APEX simulations that are over two sites, neither of which that I visited. One is in Ashland and the other is in El Reno. And these simulations simulate yield response in return to different levels of nitrogen application for different years of the sample period. Now, one of the things that you'll notice right away is, first of all, that all these yield responses naturally have, very apparent von Liebig plateaus. Not all surprising, of course, because these are yield response models. The second thing that I think you might want to notice is that the variability on the El Reno site looks to be much more significant than the variability on the Ashland site. And that you can just see the spread of the distribution here for the El Reno site is, of course, much bigger than the spread that's over here. The other thing to point out here is that while there's a great amount of variability, where the yield plateau sets in doesn't seem to vary a whole lot. I mean, it varies some, and in particular in some of the early years of the sample, for example, here in 2008, and we don't even, it almost is not even a yield plateau. But in general, the yield plateau sets in a particular rate. Now, being an agricultural economist whose family actually was in chicken farming, I have no prior knowledge of whether or not this makes sense. And this is something, of course, that the physical scientists know much more about than I do. So what we've also done with this is then we've taken this thing and we've tried to construct from it using data on historical prices and inferring a price distribution from those historical prices, what expected return from farming looks like, and what expected return, the variance of the expected return from farming would look like for each of these simulation scenarios for each of these years. And so we have in the figure here, we have two things plotted out. One is the mean response to nitrogen application. And you'll see that the mean response to nitrogen application is kind of hill-shaped. This mean response to nitrogen application, you can actually look at this and you can say to yourself, well, this is basically the mean of profit. And when you are an individual who is what an economist would think of as risk neutral, and we heard one of the farmers that was talking yesterday afternoon say that he perceived himself as being risk neutral. What you're looking for is the top of the peak here in the blue figure here. And so the nitrogen application, there's a couple of things that you want to look at here. Is first of all, these figures change a good bit year to year. Now, the reason they're changing a good bit year to year, I know has something to do with weather. What it has to do with weather, I don't know. I can't tell you that beforehand. And because it changes year to year, what that is telling us is that the farmer's planning horizon is going to depend significantly upon the farmer's perception of the weather variability and the price variability during that year. What we have modeled here is a model that is based on the historic variability. But when the farmer is making his or her decision in a particular year, they will have one of these in mind. Our idea is that they're going to have one of these in mind. What it's actually going to look like is going to depend upon the farmer, because the farmer is going to form his or her expectations. Farmers, of course, in areas that are very close to one another may have very similar pattern of expectations about both weather and prices. They may not. I mean, that is going to depend. What we're doing here is we're using the historical pattern along with the model-based pattern to make some inferences. So then what we've done is we want to combine this model that relates return measured by the expected return along with the economic measure of risk. And the simplest economic measure of risk that we can talk about is one that is the standard deviation of risk. Now, when you talk to economists, one of the first things they're going to tell you is that's not a very good measure. And that may or may not be. For about 40 years, that was the standard wisdom in economics, is that it was not a very good measure. And the reason it was is because it didn't have very attractive properties in terms of the standard model that economists use to model risk and decision under uncertainty. And that's called an expected utility model, and we'll see it in just a minute. The expected utility model has been increasingly invalidated over the last 20 to 30 years. It's been invalidated as a result of experiment. It's been invalidated as a result of observation on what individuals use, but it's still a benchmark model that economists use. But at the same time, the expected return and standard deviation model is also one that is used very frequently and is the one that predominates in the financial literature. And so for any of you who look at a stock page, or you get a stock report, you see a beta or something like that on a stock or another asset, that beta is going to reflect the risk as measured by the standard deviation relative to the market risk. And so what we think is farmers try to trade these off. The more that they are sensitive to risk, they will be willing to trade off some expected return to cover that risk, okay, to prevent that risk. And so what we have here on this figure is we've generated optimal decisions for a farmer who models his expected return very simply. He takes the expected return and then he subtracts off it a risk factor where beta tells you how sensitive the individual is to risk. And so, as I said just a few minutes ago, actually, if you go to your stock pages or anything like that, or any of you deal with a broker, this B is going to be very closely related to some of the measures of stock, or you can naturally relate it to a beta type of measure. And depending on beta varies, then in fact, we're going to get different recommendations for how much nitrogen should be applied. One of the things that we've noticed is that when you're looking at the optimal rate, you're looking for each one of these profiles for the top. And each color profile gives you a different profile about risk and return. The farther down you move in this direction, this way, the more you worry about risk. The higher you move up this way, the less you worry about risk. A couple of things to notice about this. One is that the patterns vary a lot over the years. Again, that's a consequence of the variability that we saw historically in terms of the data. And two, they vary over the different regions. Okay, so the risk and return patterns are very different in Ashland and Mino, not necessarily in terms of the nitrogen level, but in terms of the expected return. Again, this is something that I'm presuming reflects the actual physical situation, but that's something that I would leave other individuals to judge. Just to leave you with one other one, we also did the expected utility model. And the expected utility model leads to very similar type of patterns. And I would say that on average, the expected utility model comes out to be a little more conservative. I mean, what we're seeing here is that in many, many instances, it almost looks like the expected utility model, especially in some of the last years for Ashland, is saying these guys should shut down nitrogen. That's hard to believe, okay? And again, like I said, the expected utility model is very, very useful, but it has some known shortcomings. And that doesn't make it useless, but it makes it less useful than we thought it used to be. But it's still a primary model, but is going to lead to some strange results. Because when you see the pattern here in 2015 for these people who are very relatively not risk averse and things like that, you're going to see patterns of behavior that we're here saying this should shut down. And I'm talking about nitrogen application. That's hard to believe. So with that, I'm going to then again show you some nitrogen application rates here that we were getting in terms of these things. And these just summarize in different patterns here, the ones that we think are relatively reasonable here. And so I think the ones that we want to look at would be the ones that are here for the standard deviation criterion. And I'm having a little trouble with my slide, okay, because I'm trying to make it bigger than it should be. But if we look at it this way, it's this one right here on the side. I think the standard deviation is the one that I would feel the most comfortable with because we know that it's relatively robust. This is just given a very crude measure of risk, okay? The problem with the expected utility model for us as economists, we don't know what, we really don't have a clue as to what individual decision makers' utility functions look like. What we do have are ones that are analytically tractable and work well in our models, okay? But it's not necessarily clear they fit farmer behavior very, very well. And so with that, I'm just going to say thank you and say if there's any questions, I'd be happy to take them.
Okay, thanks, Bob. Quick question. Yeah, Tyson. I'll have to repeat it.
Thanks, Bob. That's really interesting. And so the risk here is, as I understand it, like the risk of achieving below expected returns is kind of a negative risk. Is there a way? Is this accounting for like what am I thinking of as an opportunity cost, like the risk that you realize less of return than what you could have? I just wonder if there's opportunity cost coming in here.
Bob, did you hear that?
He said, is there a way? And then I didn't catch too much of that. And the answer is, I'll bet there is.
I don't know if I can paraphrase accurately, but the question was, is an opportunity, the risk of an opportunity cost, is that accounted for in these results?
Well, yeah, no, I mean, that's the basic idea here is that the farmers are willing to sacrifice something to avoid risk or to diminish their risk. So in fact, reducing the risk is viewed as an opportunity cost to the farmer, something that the farmer has to forego to get the lower level of risk. And one thing I would say here is that there are much more complicated models of measuring this risk. We just took the simplest one to measure risk. So it's the most familiar, but there are a number of other models that take into account the fact that farmers don't look at risk symmetrically. We know that. Farmers are not interested in risk that has, a symmetric error both above and below the mean. They like risk that has a lot of stuff that's concentrated above the mean, and that's a one-tailed error, what we think about. And there are all ways to take this into account. We just haven't presented that in this framework here. And there's also models that will allow us to look at a farmer who takes safety first behavior, for example. We can do that as well.
Okay. All right. Thanks, Bob.
Okay.
We'll need to move on. Thank you.